Hello, everyone, and welcome. My name is Emma Houston, and I am a graduate researcher from Simon Fraser University in Vancouver, Canada. Today, I will be talking about exploring culture's influence on contempt, anger, and disgust using machine learning. Facial action units are used to map quantitative values to facial landmarks. In the area of psychology, the following action units have been found to be highly associated with the following three negative emotions: disgust, contempt, and anger. Disgust, described as a wrinkled nose and mouth, and is usually associated with AU4, AU9, AU10, AU17, and AU20. While prototypical contempt is usually a raised and tightened unilateral lip corner and is associated with AU7, AU10, AU25, and AU26. Whereas anger is a protruding teeth and tightened eyes looking downward is commonly associated with the following action units: AU4, AU5, and AU27. Culture provides humans with a set of rules to navigate various social landscapes. Although there has been recent developments investigating culture's role in emotion expression recognition systems, there is still much that needs to be done. One such hurdle is that of available datasets, which primarily contain Caucasian or North American training samples. This can lead to cultural biases when training. As well, negative emotion expression recognition performance is low compared to happiness, which usually garners around 81% accuracy, depending on what dataset is being used, whereas contempt, anger, and disgust is usually around 49% to 55% accuracy. Our solution is to implement a data-driven approach by collecting our own data across different cultures and investigating how culture's role can influence negative emotion expression. Our dataset contains three different cultural categories, the first being a combination of both Canadian and American, which we categorize collectively as North American culture, and both have high individualism scores. Individualism scores are quantitative values to describe how individualistic a culture is. After North American, we have Persian and Filipino cultural categories, both having low individualism scores. Both of these cultures represent our collectivist datasets, while the North American represents our individualistic dataset. We'll also be exploring three emotions: contempt, anger, and disgust. We collected 254 short clips, which range between 1 and 10 seconds. The whole dataset contained 27,000 frames and was over 15 minutes in total. To also establish a baseline for our dataset, we had 6 annotators who volunteered to help label each clip, in addition to the 3 data collectors who collected the clips. Each volunteer annotated the culture they best identified with and provided an emotion label that they felt best suited the given clip. Each collector also only collected clips from the culture they best identified with. Clips were then labeled with the emotion where 2 or more of the annotations agreed. If no annotator agreed on a label, that clip was removed from the experiment. After the annotation process, action units were then extracted from each clip using OpenFace, which provides an activation level for each action unit between 1 and 5. Then the predicted output was an emotion category. Our research question can be broken down into 2 main questions. The first being, how will a culture affect expression and computation recognition for the emotions selected? And secondly, how are the selected emotions expressed across different cultures that range from highly individualistic to highly collectivist? And how do these differences compare to the prototypical expressions defined at the beginning of this presentation? For our model, we use a support vector machine, which was used over 2 experiments. The first experiment assessed within cultural accuracy by training and testing on only one single cultural category, whereas the second experiment assessed cross-cultural accuracy by training on one culture and testing on one of the remaining 2 cultures. Accuracy and F1 scores of both experiments were compared, as well as comparing within each experiment to assess how each culture performed to each other. Using a one-way ANOVA and a post-hoc Tukey test, we found that most of the activation levels for each action unit normally described as prototypical for each emotion significantly differed in each emotion category. However, for contempt, action unit 10, which represents a sneer, did not significantly differ between the North American dataset and the Filipino dataset. In fact, if we look more closely, the only culture which showed a high activation for sneer was Persian. In addition to Action Unit 10, AU9, which is a key trademark for prototypical disgust, describing a wrinkled nose, did not have statistically significant results between Persian and Filipino cultural datasets. Again, if we look closer, we can see that AU9 is highly activated for only the North American dataset. The following is a confusion matrix illustrating the results of our 2 experiments. As you can see, when the North American data set is used for training, it performed the best out of all cultures for both within culture and cross-cultural training. The Persian data set performed the worst, with its highest accuracy being when trained on the North American data set, while the Filipino data set also performed similarly to the Persian data set and performed best when trained on the North American data set. The following is an activation map illustrating for each emotion across each culture what action units were activated given a threshold of 2.5. North American contempt deviated from the prototypical contempt, with the only action units being in common are AU25 and AU7. Persian contempt also deviated, with the only action units being in common AU10 and AU25. Filipino contempt resembled North American and Persian, with similar activation of AU1 and AU2, showing that much of the deviation from prototypical contempt occurring in the eyebrows, as well as the corner of the mouth. Here we can see that contempt looks different cross-culturally. For anger, the only activated action unit that resembled prototypical anger for North American was Action Unit 5, while both Persian and Filipino had Action Unit 4 activated. However, anger did look similarly cross-culturally, with Action Unit 1, Action Unit 10, and Action Unit 25 commonly being activated. Disgust for the North American dataset showed the only activation of AU9 out of all three cultures, while Persian has the most similarities with prototypical disgust, with both Action Unit 4, Action Unit 10, and Action Unit 17 being activated. The results showed that the North American dataset performed the best for both experiments, while the collectivist culture dataset performed no better than chance for all experiments. This could demonstrate a suppression of negative facial expressions to maintain harmony that was previously mentioned, or that we missed important features from these two cultures. Our activation map and the results of the one-way ANOVA did demonstrate that there were differences in activation of the action units for each culture, which demonstrates that there could be differences in how these action units are expressed and how they deviate from their prototypical descriptions. For the limitations, it is important to mention that our dataset contained both non-active and active material. Most of the active material was found in the collectivist culture datasets, while clips from reality television were commonly found in the North American dataset. Datasets were also relatively small, and images were also used, restricting our datasets. Finally, our dataset did not contain any contextual information. As we can see from the clip on the right, there seems to be, in the Persian culture specifically, lots of hand movements when expressing negative emotions, which did not occur as frequently in the North American culture datasets. Gestures and body movements could be an important feature that needs further exploring. As well, open face produces only a limited amount of features, and so exploring more avenues to gain more available data features is also something we plan to explore in the future.